I work at NodeSource and basically do kind of automation for sysops people. So I write tools for sysops. I don't do sysops myself. And that's how I came to learn about Linux containers and kind of the state of them today. So basically, we're going to be talking about containers, and I'm going to be relating a lot of things to Tupperware. It's the plan. Schedule, pretty simple, you know, kind of some history about the containers, what they actually do, how they do it. And then we're going to touch somewhat on LXC and Docker. More on Docker than LXC, and we'll discuss why. And then we're going to have a tiny demo. So we need to define some terms first because things are a little bit wonky, especially if you start using the word virtualization to mean anything because it's overused. So when I'm talking about virtualization, I'm not talking about running VMware or something. I'm talking about just any kind of software that is emulating a physical device.
Is that too dark for you guys?
Yeah.
Yes.
Cool. So we're talking purely about software there. We're not talking about a specific thing. We're not talking about the JVM, a virtual machine, and all that. We also want to talk about isolation with relation to containers. So the biggest feature that most people want from containers is isolation. Being able to say that your system is completely independent of any other system that's currently running on the machine. And that's what containers mean for most people. And then there's also persistence for containers. Not all containers actually have real persistence. So we'll go over that in a second. But these are the three things we want to keep in mind when we're talking about containers. What software is emulating what hardware? What is being isolated? And what is being saved for later use? So there are different kinds of containers that provide isolation. The easiest is like Zen or QEMU, VMs basically. What you think of with VMware, VirtualBox. These emulate a full hardware stack, device drivers and up. So they're kind of slow because everything has to be emulated. There is some hardware assistance for that, but it's still not the best performance-wise. The next is the focus of this talk. It's going to be Linux namespaces, and we're going to go over all of them today. And then BSD jails and Solaris zones are software containers. They do not fully emulate a hardware stack. They just share a kernel. So you don't need to load up device drivers again and things like that if they're already loaded into your kernel space. But they allow you to have some separation of concerns. So VMs, let's go into a little bit more. These are the big hulking things that you need if there is no option for you except for it to look like a physical machine. They aren't needed that often, but as I said, they do emulate hardware support, so you can have funky things like customized device drivers inside your VM. I don't know anybody who actually needs that. It's isolated via virtualization. That means everything in there is running software to emulate hardware to run your software. So it's kind of an inception moment there. And most of the management for VMs is done via a manager. VMware, VirtualBox, as I said before, have kind of GUIs that you can use to manage it, save state, persist things for later. Something to be clear about is there's an idea of saving the state of a machine versus just persistent disk. When I'm talking about persistence, we're talking about saving the entire state, what's in memory, what's in the CPU, etc. Because saving disk is kind of the same as just using a remote file system. So it's nothing specific to a container. VMs can generally nest. It's kind of ugly to do so and hacky to do so. So it's generally not something that we care about for VMs. So after we made VMs, well, I should say, at the same time we were developing VMs in the 90s heavily and in the early 2000s, BSD and Solaris produced zones, which were the software solution for managing your kernel isolation without fully going down and emulating hardware. So they are a kernel level of isolation. So user space, all the processes, etc., are going to be isolated from other processes, and the kernel will only talk to one set at a time. So your process in one jail cannot talk to another process in another jail easily. They are tree-like structures. So there is a parent, which there is some IPC capabilities through the kernel, but not direct communication between these. I talked about file systems and persistence. These technically don't support saving state. There are some hacks you can do to save state with services, but they don't actually support it. And you're talking about messing with assembly code to get kind of support, and it's risky. So what they do is file system determines persistence. Basically, they mount what acts as a remote file system inside of these jails or zones, and the changes are pushed out to your main mount. So technically, the parent of a zone or a jail can access the child file system. These do support resource limits, so you can manage memory consumption, CPU consumption. Sometimes this leads to odd things because since they're just isolated kernels, they don't change things like how many CPUs you have. So if you go in a zone and you query how many CPUs are on this machine, it may get back to 96, but you're limited to 4. And that's kind of terrible, but not much that they're going to do about it because their intent was never really to deal with that. BSD jails can nest, which is really nice. Solaris zones cannot. So Solaris has one global zone is what they call it, and it can have child zones, but there's only one tier deep. BSD, on the other hand, can go as many deep as you want. You'll start hitting performance problems the deeper you go.
Why would you want to nest?
So there are a couple of reasons. One, you want to restrict resource usage. That's probably the most realistic answer. So you've been allocated 4 cores for your application, whatever, by your IT department, sysadmins. And you want to be sure that some very core essential part is always able to function in real time. And you want to guarantee that it gets 1 core at all moments. So you could put a container that says, this container only has 3 cores available to it. So your container will not be affected by noisy neighbor problems. So even if they use all the CPU inside that container with 3 CPUs, you have 1 CPU that is untouched. So that's the most realistic answer. Some people will say security, but you're already in a container. Generally, you don't need more than 1 container for security problems. Platforms as a service and some hosting solutions online, it's nice because you can actually run containers and get security even though you're inside of the cloud already. In general, I've never seen anybody do it because they just spin up more machines. So Linux namespaces. Oh, I should go back a slide. So like Solaris zones are basically like a container that gives you a little slot for everything. They've got the full features that you need to have a full meal, but they're kind of bare bones. Linux namespaces are more modular. They're very ad hoc and very independent of each other. So these are not a solution that comes with all the bells and whistles. They started showing up in the early 2000s. 2002 is when the PID namespace showed up, so that's process namespacing. They isolate on a specified level. We're going to cover them, but the big ones are process, network, and file system. So when you're talking about a Linux namespace, we're not talking about a full containerization. We're talking about some aspect of the kernel is isolated from the rest of the running system. It's not virtualized. It's pure kernel, kind of like Jails is. It's just instead of going for the full kernel being isolated, you're going for small modules of the kernel being isolated. It has no relation to persistence. So Jails and things automatically mount remote file systems. These do not, and that's one of the pain points. By default, namespaces have nothing to do with resource limiting. They do nothing for this. And so you're going to need to use a separate tool. And then they're also not tree structures. They are a flat namespace, but you can emulate a tree structure with flat namespaces if you're willing to deal with it. Okay. Yep. So we're going to go over the namespaces, and this is going to look horrible and be horrible, but it's a little bit complex because each one has a specific flaw. Namespaces are always entered in one of two ways. One, you create a new process. Two, you call something called unshare. Unshare is a syscall that tells the kernel that you want to split off from your current namespace. It doesn't mean you have reference to your old namespace. You're just a new one. And they all use the same flags, which is a little bit confusing because unshare does not have the word clone in it. So, the UTS namespace. UTS is kind of the host name information about your system. It's your release version, your host name, your distro. And that can be separated out. And it's really strange if you just do this one. But you can just change uname is the only major feature of this. It's kind of interesting if you want to fake that you're another distro, but overall, this is, for the most part, worthless. The process namespace. This is what most people start caring about. This isolates your processes entirely. No amount of daemonization, forking, whatever you want to do, create a new session of processes, create a new process group, will get you out of your current process group. So, once you create a new process namespace, you're stuck in it. If you unshare two, have two process namespaces, that can still be tracked or limited by basic Linux permissions in the kernel. Generally, you can just check and see what spawned you at the time of spawning. The big note, and this kills most service managers, is PID1 is not related to PID1 of the system. So systemd doesn't work in a PID namespace because it does really crazy Linux system calls against PID1, expecting it to be the root process, and it's not anymore at this point. But each process ID gets started at 1, increments sequentially like it does normally. File namespaces are a little bit new to some people. If you don't know about mounting file systems, this basically says you can mount a new file system as root. You need to create your own mount and actually clone into it with the mount set up. So most people will chroot to where the new mount is in the new file system namespace and work from there. And I'm not going over these in detail because you're not going to use these. Nobody's going to use these. We're just kind of covering what they do. The network namespace is what separates out your internet networking, your networking interfaces. There we go. You get the loopback addresses automatically. You can't get rid of them. So that's something you need to take care of. But with a net namespace, by default, there is no way to communicate back out. So you need to have whatever created your net namespace also create a bridge and put it inside. If you're a network engineer, it's type veth to create this bridge generally, but I don't think, who cares about actually creating network interfaces? Okay, we can talk after. But most people don't care. The basic point is, by default, this is another thing you don't get. It's another kind of quirk. Most people don't even know what these are. The IPC namespace forks the process message queue and makes an independent one, and makes all anonymous pipes isolated. So, if you don't know what those are, I've never used them in production either. This is only really relevant if you're doing things where the parent process needs to create a file descriptor for IPC communication, and needs to do it on a system level rather than being able to give the file descriptor directly to a process. So now that we've covered the weird stuff, we can start moving on to actually useful things. C groups, control groups is what they stand for. These are how you do actual resource limiting in Linux, and these are what containers use. All containers use this, it's built into the kernel. They do survive session creation and forking. They're created in the same way of sorts. You create a C group and you place it on your file system, which is a little bit weird. And then you have to concat the PID of a process to a file in order to add it to your C group. So, but it's a tree structure, so you can nest things. So you can have like my web app /SQL, and that will be the C group for my web app, which has some resource limits, and then another C group for my SQL inside yours. And that's how you get something like the 3 CPUs, 1 CPU situation we talked about earlier. And there are some commands that help you. Strangely enough, these are not included with the Linux kernel or any distro automatically except Red Hat. But you can always install them, so find out how your package manager will install these, and these are what you would use to actually do it. So CG creates the file system for these. It doesn't create some sort of magical number. It actually creates files. CG classify just concats the PID number of something onto the end of whatever CG create made. And CG exec is a shorthand for running a command inside of a control group. Okay, now that we've covered all that, I'm probably going too fast, but those things we're not going to really care about after this. Linux containers. You get basically the same thing you got from Solaris Zones or BSD-JS. These can nest. But as I mentioned, all those little hoo-has before about problems with these things, we need an abstraction to actually get them to be usable. The two abstractions that anybody cares about right now are LXC and Docker. So LXC is used by a lot of platforms as a service, a lot of hosting providers that do virtual hosting on the web. And Docker is the new thing that everybody loves and nobody understands. So LXC is crazy hard to configure. Let's start with that. Like, I wanted to configure one today because I was like, okay, I've got 8 hours to do it. I couldn't do it in 8 hours and get it fully functional to the state I wanted. I even knew LXC beforehand, and it was just problem after problem. Nobody wants to use them, but they're very important to know because this is what Docker is built on, actually. And Docker is what we're starting to go towards. It creates entire kernel isolation. It still has the quirks that we mentioned before, like systemd doesn't work in LXC exactly right, but it works kind of on the new Debian. So yeah, systemd does work. It has what's called a layered file system. So layered file systems are generally, well, I shouldn't say it has. Most people use a layered file system with it. So a layered file system has the idea of you can snapshot your file system at any given time and save that state. And you're going to base all changes afterward as a diff on that old snapshot. And so this is what people do to allow quick restarts, etc. in LXC. So layered file system comes with it. And so if I create a snapshot of my file system and then I delete a file, it adds a record. So you've just used up more disk space to say that you've deleted something because it cannot delete the old snapshot. It's file. Once again, we've got shared kernel. So you need to be mindful if you're using some syscall that is not present or has changed for some reason since whatever your application wanted it to be, it will start breaking. So syscalls generally never change. Torvald is insane about this. He will cuss you out and give you death threats. This is actually a true statement. I'm not joking. But the shared kernel is interesting because that means that we can start up things in seconds. So starting up an LXC container on my laptop while it's running 2 other VMs took me like 5-10 seconds. Like, these things start up really fast because that's running through all the service initialization, everything. Okay, the layered FS, I touched on this. It can blow horribly. So Docker is built on it. I downloaded an image for Docker today that took up 7 gigabytes of my hard drive because somebody didn't know what they were doing. They didn't understand, and they kept adding binary files and then deleting them afterward, thinking that they were going away. So you need to be very mindful of this, because nobody's going to use your container if it takes 7 gigabytes to download. But, as I said before, it saves the previous state exactly, so you can roll back, which is awesome. It's very important if you're doing continuous integrations and you're using a layered FS to make snapshots after each. So you can roll back immediately and just restart the container and it's up in 5 to 10 seconds again. So, but as I said, LXC is really horrifyingly hard to create. It has a custom text file that is configured beyond belief. And you have to set up your own bridge for it to use. You have to set up its own IP address if you want it to actually talk to the outside world. You have to create the file system. It can create the layered one for you automatically, so that's what people generally do. But you could theoretically do your own. It has its own ideas about PAM, and so PAM actually stops working inside LXC unless you do a very crazy patching process to get it to work again. But they do have a patch to make it work. So, LXC, pretty awesome. I don't know anybody who's going to use this except a robot. So we get Docker. Who knows Vagrant? Yay, we got a bunch of people. So, Docker is basically Vagrant for containers. Vagrant is a command line / configuration tool for virtual machines. So it can spin up VMware, VirtualBox, a few others for you if you give it a configuration file and bootstrap them. Docker does the same thing except for it uses LXC as its container system, libvirt if it can't run LXC, and it uses systemds in spawn. This is where we get to Docker cannot nest. So LXC can nest, Docker cannot. So we're starting to get to more this idea of what Docker is. So they're getting closer to Solaris zones. It brings the same idea of isolation, but this time, instead of just bringing it, it's abstract. Yes?
You said that it cannot nest. What is I'm only partially informed on this stuff. What is the key benefit for nesting? Why do we care?
Mostly for resource utilization purposes, being able to limit resource utilization on hardware and things like that.
So nesting a database inside of an application
so
container?
say you want to make a container that encompasses everything needed to run your application. You have a web server and a database. You want to make sure the database always has one core of CPU available, because it's mostly I/O. But it needs to always be running and never deadlocked. So you give 3 cores to your web server. Well, you can't do that in one container reliably, actually. You're using process control groups, and if we're talking about a full container, they don't really like you to only use one part of the container. So in LXC, for example, you can't just say, oh, I just want to split off the resource consumption for this part of the container. It's all or nothing at that point. You could do it inside the container manually, but it's really painful. Kind of like how I was talking the LXC, 8 hours in, I couldn't get you a fully running one. It's hard to configure. Docker is built almost entirely on the asset that it is easy. It's something you can use, and it's something we're going to show you in a few minutes, because that's all it takes. Actually, it's ridiculous. So, the same idea of images, Docker has a registry of existing containers. So you can go and download Docker containers. You can search for Docker containers that have specific assets that you want. You can search for, I need this distribution, this release, and I need it to have these things installed. And they generally have it set up for you, which is pretty cool. But at the same time, if you're downloading from a registry, it's not going to have things like the actual authentication credentials you want, and you're going to have to add those after the fact and then save it again. So, but you can save it again and reuse it yourself. Just don't push it back to the public registry. But Docker is really easy to use. Its entire point is kind of to make it so you can use LXC. You can actually get containers in Linux without going and just having to learn several thousand different configuration options in order to reliably start one up. And it's thousands is an exaggeration, but it's definitely over a couple hundred. LXC is very strange and touches on all parts of the kernel without really trying to save you from it. So we're going to do a quick demo of Docker, and then I'm not doing anything with LXC because I did that for 8 hours today, and I took it out of this.
Is the demo enough?
The demo should be enough, I hope.
Give us the executive summary.
So basically, we're going to log into the Docker hub, as they call it, and we're going to actually pull something down and start running something. And I am not joking when I say this is it. This is your entire setup that we're going to do. Oh my goodness, that's tiny. Wing. It's too big. Is that good?
Yep.
Fine, it's just right.
So various distros have different ways to install it. Sometimes it's called Docker, sometimes it's called docker.io. And it gives you a big list of what it can do. In here, you'll notice there's login. Login does not let you go against a private registry. It goes against Docker Hub. So there are some hacks to get around this to host your own, but they discourage it, which I have as my main complaint against Docker. It also needs not quite root privileges, but enough that I'm just going to run it as root. Realistically, your sysadmin would lock it down with sudoers or something. I should already be logged in. Yeah, I'm already logged in. So the first thing you do whenever you're wanting to do anything with the public registry is you have to log in. The next thing you want to do is search. So what's some application we want to search for? Rails, I guess.
Apache.
Apache, Rails. Nobody cares.
Elasticsearch.
No.
Flynn.
I like Flynn. I don't know what that is. Is that how you spell it?
FLYNN.
Oh, that's just me. No, not that one.
All right. So it's got a bunch. So Flynn, Taffy, Router. I don't know what any of these do.
Happy sounds good.
We could, okay, let's try Taffy. So it kind of tries to use the same terminology as Git. So it's got pull and push, but it's a little bit confusing. I don't like it. So we're going to pull down Flynn, and it's going to download all the different snapshots and diffs on them, which I bet there are at least 2 or 3. So let's do it. 404. Oh, Flynn/Taffy. Forgot /Taffy. Oh, repository. So the dependent layers is the different change sets for the file system. So it's going, it's downloading. So whatever, I'm betting it's running on an Ubuntu because I've got all the Ubuntus downloaded already. And it's got 34.88 megs on top of that. So that's around what they installed after the fact.
How very
Oh,
meta.
oh, no, it's downloading more layers.
Taffy
Sure.
pulls repos and deploys them to Flynn.
I don't know what that means.
Very
But-
meta.
This is kind of the deal with Docker. Like, I can go and I can search for something that I don't even know how to run and get it running in a few minutes. This probably needs another thing running, so it's probably gonna fail. But
Yeah.
we can log in, we can like fire up Bash and see what they did. Whew. Got more layers. than
One
I
day.
Another 34 megs seems to be the magic number.
That's the sweet spot. Everything is just 34.
So, Brad, while this is running, can you tell us a little bit about the topology of what you've actually got running there? You started up what appears to be a Ubuntu VM.
Yeah, I've actually got VirtualBox with Ubuntu 14.10 running.
Okay.
So it's a little bit risky.
Stop playing edge.
But I like to run basically everything in VirtualBox because I can hose it and just shut it down and revert to a snapshot. Once Docker or something actually works on a Mac, I'll use that. For scripts and stuff, we do use Vagrant. It might work. We just spin up VirtualBox VMs with that. for
The
testing.
The boot to Docker, is that considered healthy or?
It's a little bit
toxic?
weird.
Finished.
It's fine. What it's really doing is booting up Core OS. So it's doing essentially what I'm doing here, except without a GUI. So it boots up Core OS to get the Linux kernel fully booted and get a proper PID1 from its perspective. And then from there, it boots up Docker inside of that.
The file system sharing is newly released with / users.
Yes, don't do that. Don't do that. It's very, very bad juju if it touches your layered file system with a shared one. Because basically what can happen is you accidentally pull or something, and it looks like nothing has changed on yours, but you, in reality, may have added an ISO to that shared folder on accident, and now it's permanently in your Docker container with 600 megs of justice. So don't do that. Just stay away from sharing those. If you're just doing it in user and it never touches your layered FS, you're okay. But I'm not really a big risk taker. So, yeah. So that was a lot of things that downloaded. But that means we can run things. So, I think it's Docker images. We'll list what images we got. Yeah. So we got Flint Taffy. And so it downloads 2 tags. So the same way Git has branches, images, repositories, kind of ambiguous term for Docker, have tags. And so we have, what is this? Latest and beta was the 2 tags that we have. So Docker has 2 options to run things. We can run against an image or against the default. And the default will try to match your operating system distribution and go from there. And by default, if it can't do that, it'll just jump into latest. But Docker is based upon the idea that you run one command at a time. So, if I want to run something in Flynn Taffy, new name, we're going to start doing resets because it's too, takes a second. Oh. Oh no, this is one of the funky ones. Okay, this is actually good. So, you'll see, this actually printed out like it's a normal command. Docker has the capability to treat containers as applications. So we're not going to run against Taffy because this is set up so when you log in, it expects some arguments and will fail if those arguments don't make sense. That's built into Docker, so you could be downloading a binary or a system image, a container, if you will. This is not a container. This is an application, which is what they want to call it, but really it's a container. It just doesn't run without stuff. But we do have my company stuff. So we have the node distribution. Yay, it echoed 1. So, we can run commands, but how do we log in? Well, what do? Just start a shell normally. You start up bash. And there's some things. 1, we need to use the current controlling terminal, T. 2, we need to use the current standard in, which is I don't know. And then we run against the containers bin bash. And that'll log us in. I put these in the wrong order. This is why I don't like demos. Sorry? Right over? Yeah, root. Root at garbage. This is your Docker process ID, which is going to get confusing. So that's what Docker is treating as a process. It's the host name of this. So we can see there's kind of our file system. We can even install stuff if we want. This comes with Node, but let's actually so on root, we added a file 1, 2, 3, and when we exit,
Do you have access to the internet from within this?
yes, we do by default have access to the internet. It does not expose ports to listen to them. You only have outgoing access by default. You can configure Docker, and I can show you in a second, how to listen on ports, but that's either a command line option or a config file option. So if I wanted to expose a port, I could do something like that. And it would try to expose port 80. It's running with sudo, so it probably would. So let me open up a new terminal besides this. So if I want to list the current applications running, you could do a PS, and we see it has port 80 TCP open, and apparently it decided to name it Eagle Franklin. I don't know. Does this not even have netcat installed? Well, it's listening on port 80. So let's show that we got it. Internet access is working for outgoing connections. Use netcat or something if you want to test it coming in. So, but I'm going to exit bash, and it's going to die entirely. There will be no save state at this point. It will persist the changes to the file system, but it will not persist the actual state of the machine beyond that. So if I go here and try to list what's running, it's gone. But the file system is still the same. We can commit the changes. Docker has the idea of commit. So whatever I use to run it is the same ID that I'd use to commit. So it had an image ID of this. So if I wanted to commit it, I would use that same ID. So I could commit that and give it a name. Law. If I wanted to. And that's how you upload things to Docker Hub. And that's about everything you need to know to get started with Docker. There is a Docker file format to help you bootstrap it before and help you kind of control the things we were talking about with configuring Linux namespaces. But beyond that, it's really meant to run applications. It's not really a full system or VM. But it's incredibly useful if you've got, say, your website and you want to run it with a single command and ensure that it has isolation. But that's about it for the demo, unless anybody wants to know anything more.
So you said that as soon as you exit out of bash, the Docker container effectively terminates. How do you make sure that the container sits there persistently serving up your application on port 80 or what have you, say in a production environment where you've got some shiny thing running CoreOS and Docker on top of that?
So generally you're going to use a service manager for that. So you use upstart, systemd, sysv even. to start up Docker and just keep it running that way.
You basically just have to have a process in the foreground, right?
You do
You
need to have
kinda
a process. It doesn't have to be in the foreground.
The
So you put
container you
background.
created had -t, which set
Yes.
it up in terminal mode, right?
Yes, it uses the controlling TTY. So it uses the current one's TTY.
If you
So-
don't do -t, it might
Yeah.
stay running?
It would stay running because it is not bound to the TTY. And I don't want it consuming the standard in. So this, haven't done this, should just be running. So it reset because I added that in front, but it should still be running over here. But it's not, so I did something wrong. There's also a really good thing on Docker. Yay! Like, I ran through this again today. Docker has an interactive repo on their site to kind of play with it without setting it up or installing on your own machine. But I don't really do it the kind of daemonized way because I don't get control over monitoring the Docker process. So I would rely on all of Docker polling and things like that rather than using systemd or upstart. So I just trust my system utilities more, I guess is what I should say.
You mentioned the Docker images exploding and getting gigantic, as you delete binaries, you're committing. What is the Docker way or better way to do that to avoid getting giant images the fast way?
One, revert to an older snapshot and do whatever you needed to do on the older snapshot. Say you're just changing one folder, but you know it's just that folder, revert to the oldest snapshot you can and just change the folder there. Two is, do you need to commit? When we're talking about persisting file changes, if they are just persisting on top of your current images, it's not going to make that diff or change set until you actually commit it. So as long as it's the same running, I don't have a good word for this, image ID, then the file diff or anything deletes and adds again are not going to be a problem.
Like cache files or something. They
Go
can get
into-
that, like, you're writing some sort of cache to disk, or I don't know. They can get regenerated.
Yeah. So,
It's basically the same concept as coded version control. You can make as many modifications as you want, just don't commit them and you won't get the diff.
yeah.
There's a squash process too for Docker. Or, I don't know if it's Docker, but I've seen people run the equivalent of squash.
You can get change sets to merge, yes, but then you get into complex situations when an error occurs in that. So you'd have to do a similar thing with a merge commit. So I don't know if you want to do that on a file system.
I've seen a couple of different Docker files install Node different ways. I was wondering which way I should do it. One I've seen is there's a PPA with like Chris Lea.
Yeah, Chris Lea now works for us, so we're of course going to argue that you should use our PPA. But we also released a Docker image, so you could just use that. Depends on what you want to do. So there is an install script for node source. I think it's dev.nodesource.com/setup.sh. You can just read what it does. Or you could pipe it to bash if you're feeling lucky. Yeah, I mean, that's an intro, I guess. Any other questions?
Have you found networking to be complicated? This, like, picturing scenarios where people are running, in a hypervisor, and then you have a bridge to Docker, and you get networking in Docker. It seems like the network layers can get kind of complicated. Does it, or is it just straightforward? You forward a port out and you're done?
You forward a port out. Docker dynamically allocates a port on the host. So when I forwarded port 80 out of the machine, inside the machine, it's forwarding port 80. Outside of the machine, it's forwarding some horrible number, probably like 50,000.
So if I had some other physical box that was running a Docker inside it, and they need to talk to each other, I need to do all the glue in between so that the forwarding port here can talk to the forwarding port there.
Yeah.
Docker helps with that too if you create the links, right?
Yes, it has
Injects
Docker
environment
link.
variables into the
And that's only if the two Dockers are running in the same box, I assume.
No, you can, it actually can export to a shell little thing for you to add. But, I mean, the layered FS is killing us when we're trying to get this into production. This is more for testing and things like that for now. A lot of people have started moving it into production, but I guess they're smarter.
Awesome. Any other questions? Cool. Let's give them a round of applause.